So you have to present group wise or anyone can present.
Anyone from the group can present. That's not at all a big problem.
So like first group 1 and then group 2 and then group 3 ऐसा कि
In a random manner. You can compile the results.
Sir, I'll present from group 1.
Group 1. Okay.
Yes, sir. Group 1 reading 3. Sir, so the
First of all,
COP
what is
value,
your experimental COP?
sir, 2.8. Sorry, just a minute, sir. So 2.8.
2.8. Okay.
8. Yes, sir.
Fine.
Yes, sir. 2.8413, sir. Sir. Sir, so for the dry compression, the dry cycle, the COP is 3, and for the wet cycle, the COP is 4.47.
है? ड्राई से वेट का ज़्यादा कैसे हो सकता है? Refrigeration effect is increased.
Yes, sir.
No, so but your
No, sir.
compression rate is more or
Refrigeration
less same only. So your
sir,
COP
refrigeration.
of wet one is better than dry.
Sir, wet में refrigeration effect decrease होगा ना sir, क्योंकि it is lying on inside
Exactly.
the
So
saturation
wet COP
point.
should be lower, no?
Okay. I took it reverse, sir. Sir. So sir, wet COP is more, I said, na sir.
Wet COP will be less. Your refrigeration effect is less. Compressor work more or less same only. So hardly any difference in dry compression line and wet compression line. So delta H would be more or less same. Refrigeration effect is increased slightly, of course. So COP of wet will be lower, no?
The COP for dry 5.55 and wet is 4.47.
Wait. Which reading, Baba? Why you are telling something
Group
randomly?
1. Group 1, sir.
Group 1. Group 1 means reading 3.
Yes, sir.
What is experimental COP?
2.8413.
Acha, same group. Okay.
Yes, sir. For dry, COP is 5.55.
5.55. CR just note down,
And for wet, 4.476.
476. Okay, okay. And your experimental value is 2.8.
8413.
2.84. Okay. Any other group?
So for group 2, I am getting dry as 5.16
Wait. Experimental. First experimental. 2 point.
Experimental I am getting it as 3.36.
Experimental we had discussed now. 2.8 was the highest one.
So the second one was 2.39 upon 0.711.
2 point, not 3 point.
So 2.39 upon 0.711, right?
2.39. 2.39. Okay, let's say
divided by 0.711. 3.36. 3.36.
Now you tell me dry COP.
5.16.
5.16 and wet?
5.14.
Bas. So 5.16 for dry, 5.14 for wet, and
3.36 is experimental.
Then what is 2.39?
2.39 is refrigeration effect.
Okay, so that is H4 minus H1 or whatever, H1 minus H4.
That is experimental, sir. 2.39.
Sir, that day we had three COPs, and I guess the group third, that is first rating COP, experimental COP was the highest, 3.7 something.
Wait, experimental COP of the first group was
Was the least.
2.84.
Yes, sir, it was the least.
Okay. Then
And
your group, second group is
3.6.
3.36.
3.36. Okay. And let's say the first group now, or the third reading, whatever you call it.
Sir, for the third batch, COP is
But it's for one.
3.785.
Take minute. I have to note down. Uh, um, huh. Yes, please.
Sir, for the third group, experimental COP is 3.785.
3.785. Oh, okay. Versus
Uh,
over here, dry
so, dry is 5.36.
3.36 and wet
And wet is 4.806.
4.806. Okay. So as such, there is no trend in the experimental values. You can see 2.84, 3.36, and 3.785 or 3.8, whatever you call it. Over here, it is something different. The first group COP seems to be quite a higher one. No, but even
So
in the
the
wet
other
zone,
problem is it is the very sensitive. So even if one two
obviously it
decimal
is.
places here and there, it will go. It will make a huge difference.
But you cannot give such kind of answer in your paper, ESC paper. There also you have to use the same thing. Let me cross check. 2.84. So Inca COP for 4.47. Okay, and your COP dry is comparatively on a very much higher side. Then second group 3.36. Okay. Mm, no, your both COP. Nee, I will say dry is okay. Wet should be on a slightly lower side. And 3.785. That means okay, first reading. So your wet COP is okay. Dry COP is also okay. Reading third group, nee, third reading, first group, whatever, that can be taken as acceptable. In the first reading, your dry COP is too high, and second reading, your wet COP is high, 5.14 and 5.16. There hardly any difference. So you can rework, I would say. Again, anybody else has tried, or only these people who have answered? Only these people?
Yes, sir.
Yes.
Hello.
Yes.
So for the first reading, I have got dry COP as 4.95.
Wait, let me write down. 4.95. Your experimental is 2.84, right?
No, sir. It's 3.78. First reading.
So this is third group.
Yeah.
But there is no point in discussion about that. No, I already declared that it is okay.
Okay.
So third reading, first group,
Experiment.
CO
You always tell the experimental first so that I can
2.841.
2.84. Huh.
So
Okay.
dry COP is coming 4.54.
4.54.
54.
Okay.
But the problem is that wet COP is little bit higher than that, 5.05.
So how you can take that reading acceptable one?
The enthalpy gap is means H1 the difference is 4, and in H2 the difference is 7. So By
So
looking
how
at the
it would
values, it's correct, but the COP is coming out to be little bit higher for
so
wet.
how it could happen? If your enthalpy difference is 4 and compressor work difference is 7,
Yes, sir.
so how it could happen? Well, hardly there is any difference, correct? Or those two lines are almost like parallel. So whatever are the values H2 minus H1 for wet and H2 minus H1 for dry, there may be difference of 1 or maximum 2, and in that refrigeration effect part it is 4. So naturally your COP has to be higher for the dry compression type. It's quite a logical thing.
So can I share the screen?
Yes, I might.
Yes. So this one, sir. Is it visible?
Huh.
Uh,
Zoom it.
yes, sir.
Hmm.
So this difference is coming out to be 4 and this is 7, but still uh, the COP of wet is coming out to be a little bit higher.
Tell me H2 dash minus H1 dash and H2 minus H1.
Yes, sir. Here.
H1 is 360. Your one is for the dry part, right? Huh.
Yes, sir.
382. And then 356 on this side, 375. So H2 minus H1 is 22, correct?
H2 minus H1 for
82
dry.
minus 360. 82 minus 60 is 22.
Yes, sir. Yes, sir. Yeah.
And over here, H2 dash and H1 dash.
Here,
75 minus 56. So 75 minus 55 itself is 20. And this is 19. So your wet work is reduced.
yes, sir.
So that is the problem. Try to find out the values as close as possible to the precise one.
Okay, sir. Okay.
Zoom the figure, zoom the figure. So why you would say that the gap between 2 dash and 2 is more as compared to 1 dash and 1?
So it is less. This is
Taking as
4.
the parallel one. Now, if you observe point 1 and 2,
Yes.
then 1 is falling, let's say, almost on the isentropic line, correct?
Yes, sir.
And your 2 is slightly deviated towards the right hand side. Why? If point 1 is on exactly, let's say, exactly on the isentropic line, then point 2 also should lie on the isentropic line only, correct? Why it is on the right hand side?
So it was a little bit on the right.
Why? Point 1 is on the isentropic line, exact isentropic line. Then point 2 also has to be on the isentropic one, no? That is what you call as the isentropic compression. If it is falling between two isentropic lines, then your linear interpolation should be there. If fortunately your point 1 is on the same line,
Yes, sir.
isentropic line only, then why 2 should differ?
Yes, sir. Yes, sir. Oh.
Which group is yours?
First group, third reading.
Experimental COP.
2.841.
2.84. So other people from the same group, Suraj and Ritik, those who have given the answer. Can you observe this? Your point 1 is on the isentropic line and point 2 is on the right hand side of the isentropy. How it is possible?
So before this, I darkened this, but it was slightly in the right. But yes, sir,
Why
it
it
should
would
be. I think it should be on the line itself.
on the line because your point one seems to be on the line.
Yes, sir. Yes, sir.
So your point two also has to be on the line.
No,
Whenever
sir, but
Yes.
point one falls in between, then your point two has to be calculated in the same ratio. Correct?
Yes.
So your group for 2.8 for experimental value, your dry COP is on the higher side. Wet COP is okay. 4.476 is okay.
Yes, sir.
5.55 is too much higher side.
Sir, I will do the calculation again and see.
All other people also from your group.
Yes, sir.
sir, for the same reading of Shrikant sir, like the first point is very like negligibly away from the isentrope sir, like 0.5 mm or something. But
Yes, sir. It
even
was
if we round off to 1 mm
slightly
also, na,
different.
sir, the COP changes drastically, sir.
So that is what is your skill now. I told very first time the same thing.
But sir, the margin of error is so vast, sir. So like,
So obviously, if I ask you to solve it in your EST or MST paper, you cannot argue with such things. That is why I'm making
yes, sir.
you to have that practice over here.
Okay, okay, sir.
So for batch 2, that is experimental CO2 3.36.
3.36. Okay. Second group.
Yes, sir. Sir, I'm getting dry COP as 5.1 and wet COP as 4.83. 83.
4.83.
Yes, yes.
Wait, let me check. 4.83 or dry is 5.16. Okay. Third group is getting 4.806. So which is related to this part. Oh, so that means slightly higher.
Yes, sir.
4.806 के थोड़ा सा ऊपर है 4.83. So either the third group has to get the wet part something more than 4.83 or you should get it even lesser than 4.83. The experimental trend is not getting followed.
Sir, for
Sir,
the
full
Wait,
group,
wait, 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 wait. I have to. Yes.
sir, for the experimental COP 3.782,
Hmm.
sir, actually I was getting wet COP as 4.23 and dry as 5.5.
Wait, 4.23
Yes, sir, and
and
5.5.
5.5.
Yes,
Wait,
sir.
let me check my values. 5.5 may be higher, but that is okay. And 4.23. 4.23 is too low, na?
Yes, sir. So that is why I didn't tell, but now because we were looking at the trend, so yeah, that's why I.
So it has to be on the higher side because your experimental value is the highest one. 4.23 is lower than 4.83.
Yes, sir.
sir,
If you observe the trend, 4.476 is okay, 4.83 is okay. Now the third group has to get the reading more than 4.83 or the second has to get the reading less than 4.83 so that it will match.
Yes, sir. Yes, sir.
4.23 is not acceptable, that is
Yes,
too low. 5.5 may be okay because 5.16 and 5.36 is as same as 5.16 and 5.5. That doesn't matter.
yes, sir.
sir, actually I recalculated group 1 third reading. experimental
Experimental
2.84413.
2.84. हाँ.
Yeah. So the dry is coming 5 and wet is 4.47.
4.47 is okay.
Yeah.
हाँ,
And the
dry is
dry is 5.
5.00 exact.
Yes.
Okay.
Yes, sir.
So we can say 5, 5.16 and 5.36 is okay.
Yes, sir.
So that way there is a trend. Experimental already we have checked. Now the only thing remaining is for the wet part. So 4.47 is okay, and either the second group has to get something lesser than 4.83 or the third group has to get something more than 4.83.
Yes, sir.
Hello, sir.
Yes,
Sir, group 3, 3.785 experimental.
3.785. Huh?
Sir, I'm getting the dry one as 5.36.
That is
Sorry,
okay.
5.21 and the wet one as 4.95.
5.21.
Yes.
5.36 seems to be okay because 5.16 and 5.36. This is okay. 5.21 would be very close. And your weight is, weight is
4.95.
4.95. So this will show some trend: 4.47, 4.83, 4.95. And what is your dry value you said? 5.21.
21.
4.95 and 5.21. That is also acceptable one. 4.83 and 5.16 is also the similar range. Hmm. Wait, 4.95. Okay, and 5.21. 5.21 is okay. This is much closer. 4.95, 4.83, and 4.47. So here I would say 4.47, then 4.83, 4.95. Okay, let us finalize this trend. So someone should note down the values. Experimental values I am saying in the higher order means increasing order 2.84, 3.36 and 3.785. Correct?
Yes, sir.
Yes, sir, correct.
So uske against write down for the wet part 4.476, 4.83 and 4.95. And the dry order is 5, 5.16 and 5.21. Okay, so you exchange the calculations, those who have got these readings, and then you can prepare your result. Okay, now this part is over as far as the calculations are concerned, the trend is concerned. Now you tell me the conclusion. Let us discuss and
Dry
finalize.
is greater than dry COP is greater than wet COP.
That is what is the observation.
Sir, dry is giving us, sir, more refrigeration effect as compared to the wet one.
Why?
So the actual cycle is most probably a wet cycle.
What is the nature of your cycle? Experimental.
It
Sir,
should be wet, right?
the wet cycle.
Completely wet. Correct? It is completely wet, even on the left
Yes,
hand
sir.
side of the wet compression.
Yes.
Now, anyone can share the uh, what you call graph, pH chart, any group, doesn't matter. श्रीकांत हो या कोई भी.
Yes, sir.
Anyone can share the pH chart of your respective readings. Am I clear?
Yes, sir, I'm sharing.
Sir, I'll check.
Sorry? Just zoom the cycle. Okay. So now what you can see over here is your wet COP is lower than the dry COP, which is a theoretical part. Because your isentropic compression lines are almost like parallel one. There is an increase in the refrigeration effect from wet to dry, which is obvious part. So that is why your wet COP is always lesser than the dry COP. This theoretical part we have confirmed. Everyone agrees?
Yes,
Yes.
sir.
Now either Shrikant or anyone can share the screen with the readings. Not this. Input readings. Input values. Observation table. I want the observation table of all three readings. Anyone can share. Group 1, Group 2, Group 3.
So these are the values.
Where are the. Okay. So this is our experimental part. So what you can observe with this? What is the general observation regarding the condenser pressure?
Sir, decreasing.
Okay, fine. By how much amount? Let's say you are plotting it on the chart. By how much amount?
Around point 0.3, 0.03. 0.03.
0.03 MPa. Is it a very big factor?
No, sir.
Fine. What is the observation regarding the evaporator pressure?
Sir, same decreasing.
How much amount?
Negligible.
0.21 approximately.
0.2?
0.15,
0.02.
0.15.
0.2 कहाँ से आया, 0.15 कहाँ से आया?
0.02, sir.
Sorry, 0.02, sir, 0.02.
हाँ, okay. So is it a substantial amount?
No, sir.
No, sir.
Okay. So can we declare that the evaporator pressure and condenser pressure more or less same? Not
Yes.
exactly, more or less same. So if you try to superimpose all three graphs for all three readings, then your condenser pressure and evaporator pressure would be more or less same, not a very drastic change. Do you agree?
Yes, sir.
Okay. Now you observe for Shrikant, you are having the what I can say. This is observation table. So
Yes, sir.
result table also.
Yes, sir. Yes, sir.
Okay. So don't share it right now. I will tell you. Fine.
Yes, sir.
So now your second column, नहीं, serial number है ना, ठीक है. Third column and fourth column are declared more or less same. Okay. Your next column TW1, water inlet temperature, that is exactly same, 30 degrees. Correct or not?
Yes.
Yes, sir. Yes, sir.
Yes, sir.
TW2, that is water outlet temperature, that is decreasing,
Yes, sir.
right? 24, 22, and 20. Now, what does this indicate? That your delta T is increasing. 30 minus 24, 30 minus 22, and 30 minus 20. Correct?
Yes, sir.
Okay. Now you tell me accordingly. Acha, Shrikant, can you show about this Q absorbed values for all three?
Yes, sir. I've written. I'll just click the photo and share again. Yes.
Okay. You keep this photo also open, means don't close it,
Yes, sir. Yes.
hide it.
Yes, sir.
Has your class done any laboratory course under me before this RAC?
No, sir.
I had not taken your heat transfer course, right? It must have been online only.
Yes, sir. Gulane sir had taken online.
Online only. Okay. Fine. So before sharing this or simultaneously, let me share few things from my side. When I engage any laboratory course, then I want all my students to be absolutely clear in their mind about the three W's. So why you are doing any kind of thing. Or rather, first of all, what you are doing, that you have to be clear, because your Viva is based on all these questions only. So what you are doing, you have to be clear. Then why you are doing so, that also has to be very much clear. And the third question is how you are doing it. Because the methodology which you adopt for executing any practical will have its own limitations, advantages, whatever it is. So accordingly, your answer is a very strong function of the methodology which you adopt. Do you agree?
Yes, sir. Yes, sir.
Fine. So as far as this experiment is concerned, now I hope you are clear with what you have done. You have taken the readings, water flow, and etc. etc. Then why you have done? So this question is more related towards the objective of this particular experiment. So we want to measure the performance or COP, whatever you call, of this water cooler. You have seen the water cooler practically. Your batch is fortunate to be on campus at least till your second year. Correct? It's not like you have not even seen VJTI. So you have seen the water cooler. One at the workshop, the other at the extreme end of the corridor, and then third at structural department, and so many. Now you observe the readings Let us discuss with respect to that only. So what you are doing over here in the second column, what is your observation? 9 second, 14 second, 20 second. What is your observation?
So m dot is decreasing.
M dot is decreasing. Okay. And your delta T is increasing.
Yes, it's
Now, Shrikant, you showed the Q absorb.
Yes, sir.
What is happening to the Q absorb part? Huh.
it is
Okay,
decreasing.
Q absorbed is decreasing 2.79, 2.39, 2.09. Okay, whatever it is. Okay, fine. And what about your compression work?
So almost remaining same.
Approximately same only, sir.
Almost same. So, if you try to analyze the situation, your COP, which is having in the numerator as the refrigeration effect, which is decreasing, correct? And compressor work almost the same. So that is why your COP is decreasing, correct?
Yes, sir.
3.78, na? 785, 3.36, and 2.84. Fine.
Yes.
Do you agree with this?
Yes, sir.
Yes. Now you try to analyze the situation practically. Your energy meter reading, why it would change? Huh? Well, is there any
Compressor
fluctuation in
takes
the
more or
electrical
less.
part?
Yes, yes, sir. There is
Compressor
fluctuation.
RPM same, then mass flow rate of the refrigerant same, everything is same. There is no electrical fluctuation. So your energy meter revolution would be more or less same, correct? The time required also same. So that is why your compressor work is more or less same. Do you agree with this?
Yes, sir.
Yes, sir.
Okay. Now you have observed the water cooler in the cottage premises itself. What you are changing is the mass flow rate. Correct? The time is increasing 9 seconds to 20 seconds. So that means your mass flow rate is decreasing and correspondingly your delta T is increasing. Do you agree? M dot reduce होगा तो delta T
Yes.
increase होगा. Do you agree?
Yes, sir.
Yes.
But still your COP is reducing, out of which your compressor work is almost constant. So that means your Q absorbed is reduced. So now think why this would happen. Ideally, whatever is the rate of reduction of m dot should be equal to the rate of increase of delta T. Do you agree? Why
Yes,
heat
sir.
exchange would change? M dot into Cp into delta T. So whatever is the rate of reduction of m dot should have been same as the rate of increase of delta T. Everyone agrees with this or not?
Ideally, yes, sir.
Ideally, yes. So practically it is not happening. Why? I will tell you about the requirement from my side during the laboratory course. I do not want a single sentence in your conclusion which can be declared as observation. The observation is different. COP of dry is greater than COP of wet. This is observation. This is not conclusion. Okay? Or whatever your m dot is increasing, नहीं क्या है आपका m dot कम हो रहा है ठीक है fine. Reducing and delta T increase. This is observation. I do not want observation. What you conclude out of that, what you analyze out of those readings. Increasing, decreasing, remaining constant or whatever, this is not certainly the conclusion. Do you agree? This is simple observation.
Yes, sir.
Whatever the way your previous laboratory courses would have been executed, I don't know. I have no authority also to comment about that. बट माई लेबोरेटरी कोर्सेस अगर आपका हीट ट्रांसफर होता तो उस टाइम में पता चल जाता. You have to link the practical aspects with the theoretical knowledge which you have gained. That bridge has to be built between your readings and the theory whatever you have learned, and then accordingly you need a conclusion. So our first point of discussion, as far as finalization of the conclusion is concerned, is that m dot is reducing, delta T is increasing, this is okay. But practically it is not with the same rate. Correct? Theoretically it should have been the same rate. Other m dot half होगा, तो delta T should have been raised by 2 times, correct? So that Q would be constant. Now Q is not constant, this is what we have observed. So why this would happen? Are you getting the point clear or any doubt going on? Any doubt?
No, sir.
No, sir.
Okay. So hopefully you are clear with the point which I have expressed. That is why I requested Srikant to keep the result table as visible to you. So let's look at the readings. Your m dot is reducing, delta T increasing, but not at the same rate. What is the physical interpretation of this?
Sir, the evaporator, while we are plotting any cycle, we are assuming all the processes to be reversible, right?
No.
Yes, sir. So
Why?
that's how we are able to plot it, right?
No, we are not using the Carnot cycle. This is a vapor compression cycle. Why it should be reversible?
So then we should have plotted using dotted lines, right? We are using solid lines to plot all the graphs.
You can plot it by dot line. No problem. We are using the solid lines just for the sake of our, what I can say, convenience. Theoretically, it is wrong only. You have to draw a dotted line. But what change it would make with that?
What I was thinking that the something like isentropic efficiency for a compressor and a turbine, and something which is expanding the working medium. So we actually see this in we use isentropic efficiency to declare that there is a temperature difference. Ideally, the temperature difference should have been this, but there is a temperature increase or decrease with regard to being it a compressor or a turbine. So the process should have followed some path, but due to some internal irreversibilities, the process has not followed the path, or there is a difference in temperature, even though the mass flow rate, even though ideally the mass flow rate by the amount of decreasing, the rate at which the mass flow rate is decreasing should have been same uh, as the rate of increase of the delta D. I think something related.
No, I will answer you. I will answer you. The first part you discussed was related to the compressor part. We have already considered the compressor, what you call, efficiency, isentropic efficiency or mechanical efficiency, whatever you call it, correct? And we practically observed that the energy meter reading and the corresponding compressor work is almost constant. So this is something experimentally verified. This is not theoretical prediction. 0.7 कितना है वो?
Yes, sir, 0.7368 and 0.7118.
Whatever. Correct.
No, sir,
So
I'm not.
experimentally verified. Let me complete.
Yes, sir, yes, sir.
Okay, so something which theoretically can happen as internal irreversibilities, we practically verified that the amount is very small, negligible, almost negligible. Okay, second part related to the expansion which you discussed. So here for all the three readings, our assumption is same, that it is isenthalpic expansion. It's perfectly vertical line between 3 and 4. So whatever is happening with the change of the mass flow rate With respect to the expansion, there is no link. Same is the logic for the compression also. I have just proved that even if you change the mass flow rate via the compression voltage,
Yes, sir.
and we have already seen it experimentally that it is more or less the same one.
Yes, sir.
Because your pressures are also not changing.
Yes, sir.
Had you ever observed that the COP of the water cooler, you use the water cooler to fill the water bottles, whatever, correct? So is it like you make the water to come fast out of the system, then the COP is better, and when it is on the smaller side, then the COP is worst. Is that the practical situation? We just press the tap
No,
and the
sir.
water comes out. It's a practical system. ऐसा तो कुछ है नहीं कि you press the tap and sequentially or in some particular manner so that to control the mass flow rate. वरना तो हर किसी को ऐसे ही करना चाहिए ना.
Yes, sir. So,
So
but
your higher mass flow rate uh, is having the lower COP, correct?
no, sir.
Where are the readings?
Sir, higher mass flow rate has
Not-
higher COP.
नहीं, you show me that m dot. Okay. So 1 by 9, 1 by 40 and 1 by 20. Okay. So 1 by 9, that means higher mass flow rate. So over there it is a higher COP. So is it like that if you mm, turn the knob or rotate the knob of the water cooler slowly, then your COP is worst, and you put it as the fast one, fastest one, then your COP is the highest one. Is it the case? Here he says that whatever is the mass flow rate, correspondingly delta T would be there. If you put it fast, mass flow rate, then your delta T will be lower. If you put the mass flow rate on the lower side, then delta T will be heavy. The same thing you can imagine very easily at your domestic water heater. You call it a geyser or whatever it is. करेक्ट. अगर आप मास फ्लो रेट कम रखते हो तो पानी ज़्यादा गर्म होगा. अगर मास फ्लो रेट ज़्यादा है तो पानी कम गर्म होगा. You might have observed this at your home also, correct? So
Yes, sir.
ideally, whatever is the m dot, there is a corresponding change in the delta T. Well, what
Yes,
we
sir.
have observed over here is there is a change, but not the corresponding. The rate of decrease of mass flow rate and the rate of increase of delta T, they are not proportional. What could be the reason?
So, sir, basically, this has nothing to do with the cycle, right? So, cycle is
No.
basically fixed.
Why it
So,
would
there
be
is
related
some
to
issue
cycle?
with the water which is being pumped to get the refrigerator. Basically, the storage space has some issue.
Storage space? What is storage space?
So, the water which is being cooled.
Evaporator, huh? Okay, fine.
No, sir, evaporator is basically extracting the heat from the water which is flowing, right? So, there are two systems, right? A cycle which is the refrigeration cycle and a water pump which is pumping water at some inlet
Water is
temperature.
just as a medium through which it will extract the heat.
Yes, sir,
Otherwise, this
exactly.
would have been, जो मैंने आपको वीडियो दिखाया था, this would have been a
Yes,
static
sir.
water.
Yes, sir, static also.
हाँ.
Yes, sir. So basically the cycle is fixed, and even and when are the
In the
changes we have,
practical, what you have changed only the mass flow rate. Correct?
mass flow rate we have changing. Yes, sir.
We have observed that even though you change the mass flow rate, your condenser evaporator, both pressures are almost the same. You have observed that your compressor work is also almost the same.
Yes, sir.
Your COP is reducing. So in the denominator, compressor work is same, but COP is reducing. That means your heat absorbed is reduced, and which you can verify from your result table.
Yes, sir.
Shrikant, where is heat absorbed?
Yes, sir.
It is
Kilowatt,
there.
2.79,
Yes,
and
sir.
then
Heat absorb.
2.39 and 2.09. Okay. So why this would happen in reality? That is the question.
Sir, if you see the readings of temperature difference, sir, they are decreasing, increasing. Sorry. So,
Uh,
sir, the temperature difference is increasing. So we can say the delta T part is increasing, and irreversibilities are increasing. Hence, the COP is decreasing.
What kind of irreversibilities?
Sir, both internal and external irreversibilities
Explain.
of the surrounding and as well as inside the system.
Explain. If you are claiming something, you have to be able enough to defend for that. What kind of internal irreversibilities? What kind of external irreversibilities?
Sir, like the compressor efficiency, we can say,
Compressor efficiency कहाँ से आ गई? We are
sir.
discussing only about the m dot and delta part, delta T part, which is related to the evaporator.
So, sir, the more the delta T part, more the internal reversibilities.
But that has nothing to do with the compressor, right?
Yes, sir.
We have already cross-checked experimentally as well
Yeah,
that the
yes, sir, yes, sir.
compressor work is more or less same.
This can also be due to
It is
error
not
in
changing only.
apparatus or something.
What?
Error in the apparatus or something.
Yeah, what kind of error?
So like
Don't
first
claim
we did
anything.
the first process, right, where suppose the mass flow rate was 1/9. That then we didn't let the apparatus completely come to steady state and then did the next experiment. So
That
we
is
might
your
get a
duty.
higher delta T instead of the
No,
actual
that is
value.
your duty. You have to wait till the temperature gets satisfied. When I say delta T means I mean to say water inlet temperature is anyways fixed 30 degrees Celsius. Water outlet temperature when you measure, you have to be sure that it is a static one, steady state. Let it take 5 minutes, 10 minutes, 15 minutes, doesn't matter. आपको ऐसे थोड़ी बोला है कि मास फ्लो रेट चेंज करो और इमीडिएटली टेम्परेचर लो, उसका तो कोई फर्क ही नहीं आएगा. यू हैव टू मेक इट टू द स्टेडी स्टेट, देन ओनली यू कैन से दैट m dot and delta t both are stable. हम m dot क्यों लेते हैं 1 लीटर का? Because we are putting it as to nullify the errors, minimize the errors, correct? May not be nullify, but minimize. There may be water fluctuation in the flow rate, correct? So we take it for a larger quantity, 1 liter, 2 liter, take the time, and what we take is a time average, correct? So similarly for the temperature also, you have to wait till the temperature gets steady, and then you note down the reading.
Sir, maybe because of environmental losses, sir.
What kind of losses?
Like for third reading side, we take 20 minutes to fill it to 1 liter, sir. Till that time, there are more environmental losses. And as compared to the first case, that it takes only 9 seconds.
Be specific. I'm telling everyone to be specific. Don't give loose sentences.
Sir,
What kind of losses?
Sir, the actual
heat
delta
losses,
T could be higher.
Sorry?
So the actual delta T could be higher because of the heat losses.
Why?
Yeah. So because the process we are assuming to be isentropic, right?
Isentropic? Heat transfer isentropic?
Sir, like
wait. Let me complete one. You are not allowed to interfere. Isentropic heat transfer?
No. So the temperature which we have measured for suitability, so the actual value could be lower.
No, please justify. You are saying that the isentropic part is a what you claimed as the theoretical one. The isentropic is related to the compression part. What we are discussing is m dot and delta T is related to the evaporator. Are you focusing towards the compressor or the evaporator?
Towards the evaporator. So that is what happened. Towards the evaporator.
Evaporator. तो वहाँ पे तो isentropic का कोई लेना देना ही नहीं ना. Now next person.
Like sir, I was saying ki for the 20-second timer, like the delta T should be more ideally, but because we keep it for 20 seconds in the environment, so like there are heat losses to the environment, therefore we get an increased delta T, like the temperature of the water rises.
Do you stay in Mumbai?
Yes sir.
So come over here and do the experiment.
Uh,
So
That is the only answer I can give. You are blaming something without any proof.
so it can be either due to the evaporator structure, right? Because
Structure. What is the structure?
so means basically it's a heat exchanger. If we say at a point, means it can be the cross feed or it can be a parallel feed, right? So now if we are increasing the mass flow rate, it might happen that basically the fluid is not getting a sufficient time to transfer the heat.
Why?
uh,
Why do you think so? Because of higher mass flow rate.
yeah, I'm somewhat, my thought is going over that side only, that if we increase the mass flow rate, then basically the
But your
time.
observation saying that the higher mass flow rate is higher efficiency, higher COP. लोअर मास फ्लो रेट रिजल्ट्स इन लोअर सीओपी. आप उल्टा सोच रहे हो ना कि मास फ्लो रेट बढ़ा दिया तो टाइम सफिशिएंट नहीं मिलेगा. So that means your performance has to decrease with higher mass flow rate. Here it is showing that higher mass flow rate the COP is higher.
Sir, I would like to add something that Ritik already said. That the he was talking about the irreversibilities in the inlet condition and the outlet condition for the water pipe, which is releasing the heat to the evaporator. So you asked that how is the irreversibility is increasing. So basically, if I use the entropy formulas, so it is MCP ln T2 by T1, right? And plus the ln plus plus R ln P1 by P2, and we are saying that the pressures we actually have
Is this formula acceptable
not
to substance
accepted
like
for.
water
Yes,
or
sir.
the refrigerant in the liquid phase? All these formula related to the vapor phase.
Yes, sir.
Ideal gas behavior. None of them is ideal.
Yes, sir. It is not really right. So we would have then gone for the writing the available energy at 1 and 2, so that we would have uh, understood how much is the irreversibility related to the process. I was
How
just
will you
giving an
measure it?
insight that
Yes, how you will measure it?
sir, we have the available energy function, right? So it is.
For the liquids?
Yes, sir. It is a function for any substance, right? So we can write it for inlet and outlet, basically. So in this case, we will use available energy function would be h minus t naught s plus half v square, right? So something like that. If we write, so then maybe the why there is a temperature difference from the ideal, why there is a deviation, we would be able to understand that. I suppose. I am not sure. I will have to write the equation, but maybe yeah. But yes, what Ritik said is I absolutely agree on that. There will be a increase in irreversibilities. That is why we are deviating from the ideal values.
Then you do the calculations and tell me. I have
We
not
don't have.
denied that Ritik was wrong. I'm just trying to take out the, what I can say, the factors which Ritik said as the irreversible. What are those factors?
Sir, as you said, sir, that R ln P2 by P1 and sorry, CP ln T2 by T1 minus R ln P2 by P1 is for vapor. So, sir, similarly, we can use for
Not
liquid
vapor,
also,
that
sir.
is for the ideal gases.
Yeah, but sir,
Ideal formula for
entropy is
ideal.
a point function. So, sir, we can use it for uh, uh, just to calculate the entropy change, right? So we can use that
No,
equation
no,
for.
no. All those
No, no,
formulas
no.
which you are telling are related
For
by,
ideal
they
gases.
are derived now by using PV is equal to MRT.
Yes,
That
sir.
is not
Yes, sir.
valid for liquids. is equal to MRT for ideal gas.
Sir, then we have also the equation for entropy for a heat exchange that is mc/dt. So mc ln T2 by T1.
Entropy or entropy
That,
change.
yes, sir. That's the entropy change for a system that is exchanging heat with another system. Finite systems exchanging heat with one another.
Okay.
So in case of water, we have water also we fix the C. That is there is no CP and CV, right? So we fix the C.
Incompressible.
Yes,
So
sir. So as we can see for the initial readings, the delta T is less. So ln T2 by T1 will be on a lower side. And as we are moving,
I disagree about implication or rather implementation of this formula itself. How
yes,
you
sir.
can apply it during the phase change?
uh,
Refrigerant is changing the phase, you are applying it to water. Okay, fine.
Sir, but we are not applying to the refrigeration cycle, right?
Agreed, now you are applying to the water side.
Yes, sir.
Where there is no phase change, it's only the sensible part.
Yes, sir.
In the evaporator section, means the refrigerant side, it is the latent heat rejection.
Yes,
Sorry,
sir.
absorption. And
Yes, sir.
water is giving the sensible heat rejection.
Yes, sir.
So, how you can apply
So,
for this incompressible value for ln T2 by T1 and all these things? I am very much doubtful about this. To the best of my knowledge, you cannot apply it directly.
Sir,
sir, so
for
then, bol Ritik.
uh, right. So, sir, I was saying that for different processes, we'll apply different equation.
For different working substances, also you need to consider whether it is a gas or the liquid or what, solid also. In the
Yes,
solid
yes,
also
exactly,
there
sir.
is entropy change.
Yeah, so for different processes, we'll consider different equation, right, sir? Sir, for let's say our refrigerant is in vapor state, so we'll consider the bigger formula of Cp ln T2 by T1 minus R ln P2 by P1. And if it's liquid, then we'll consider C ln T2 by T1 because C is a constant there for liquid.
No. I'm doubtful about using that
Yes, sir.
part directly.
That formula was actually derived for two systems exchanging heat, finite systems exchanging heat. So, sir, then,
What kind of working substances?
yes, sir, we can't actually, I also agree on, but I was just, some formula so that we are able to understand basically the gain because the trend will be somewhat similar, right? So, the
What I
temperature.
can say for this particular discussion is that point is correct, interpretation is incorrect. There will be some irreversibility because of what?
But the temperature, actually during the evaporation and the condensation process, we have assumed the temperature to be constant. But
For the refrigerant.
yes, sir. We have assumed that it's constant, but in reality, in actual cycle, it's not the case. That
Why?
So
There may be sensible part, there may be latent part. जब phase change होगा तो temperature by default same है.
So there are many factors like there is superheating and subcooling happening in actual cycle. So what superheating does is it increases the means whatever the increase in temperature.
Let me just interfere you. Even if you consider superheating, that is towards the compressor part. Are we discussing anything about compressor? No. Even if you consider the subcooling part, that is common for all three. Whether it is reading 1 or reading 2 or reading 3. So whatever may be the change in the refrigeration effect will be like same. No? Why there would be any change in the trend? We are discussing the change in the trend, not the values. I hope I'm clear.
Yes, sir.
We have focused towards the evaporator, correct? The rate of decrease of m dot is not as the same as the rate of increase of delta T. Now this entire thing is focused towards the evaporator. There is no sense of any subcooling. Means even if you consider subcooling, still it is common to all three. what will get shifted towards the left hand side is that vertical line, correct?
Yes, sir. But in compressor, while means the refrigerant goes from the compressor to this condenser, right? So we have assumed the compression process to be isentropic, but it's in reality is not so.
उससे होगा क्या? For all the three readings, you are having that same assumption. What
Yes, sir.
we
But
have observed is the trend.
the higher temperature, what we assumed in reality, it will be.
I agree with you 100%. 100% agree. उससे होगा क्या?
Delta T increase होगा.
Which delta T? You are totally confused. Which delta T? I'm talking about mass flow rate of the water. You are talking about the refrigerant at the exit of the compressor. Both have nothing to do with each other. Water is in the evaporator, not compressor or condenser. Which delta T you are talking about?
Yes, sir. Yes, sir. So, sir, so in evaporator itself, there can be some temperature loss from the system to the surrounding.
अब वही ना गाड़ी लाइन पे. Ritik
Yes,
also told the same thing. What kind of losses?
sir, heat loss.
What kind of reversibilities?
Heat loss that is happening between the refrigerated space and the surrounding. So because of that,
which heat losses? Don't just blame. You have to prove. Which kind of losses? कहाँ पे होंगे?
और सर लॉसेस तो तीनों केसेस में होंगे सर ऐसा.
तीनों केसेस में होंगे. Yes.
But losses will be proportional to the heat loss, right? I mean the temperature difference, right?
Let it be. You have to prove which kind of losses would be there, which you are saying as a function of the delta T, or indirectly m dot only, na, because who will change the delta T? M dot only. If you change m dot, then only there will be change in delta T. So you are saying losses are proportional to m dot. Prove it.
sir, there's also the frictional losses. I mean.
Those we are neglecting in all the three cases, so forget about that. Have you considered like friction loss in reading 1 and neglecting reading 2? No.
Yes.
जो भी frictional losses है तीनों में है.
Sir, with the previous discussion, we are not able to pinpoint what is the irreversibility, but we can analytically find why there is a temperature difference using the heat exchanger formulas, I guess. So
Heat exchanger formula. Wait. Huh? What is this?
Sir, LMTD values, because this is basically parallel. I hope it's a parallel flow or something parallel. If I'm assuming it's a parallel flow.
Assume init flow. क्या फर्क पड़ता है? Parallel.
Yes, sir. So the evaporator is holding its temperature at a constant value, right? And the water which is getting cooled.
LMTD कैसे निकालोगे? एक में phase change है.
हाँ सर, LMTD निकाल सकते हैं ना सर. LMTD अपने को दो इनलेट और आउटलेट पे टेम्परेचर डिफरेंसेस पे निकलता है ना सर. LMTD द मीन टेम्परेचर डिफरेंस बेसिकली.
इवेपोरेटर का क्रॉस तो सेम ही आएगा ना.
सर LMTD इन दोनों के इनलेट आउटलेट टेम्परेचर डिफरेंस बताता है ना सर. मतलब इवेपोरेटर का आउटलेट माइनस वाटर का आउटलेट तेरा अभी अपना θ2 हो जाएगा और
सब्स्टिट्यूट.
यस सर. सो फॉर एग्जांपल अभी अपने केस में आई एम नॉट श्योर रेफ्रिजरेशन का टेम्परेचर कितना था. आई गेस समथिंग अराउंड जस्ट बिलो 20 डिग्री सेल्सियस आई गेस. और अपना जो आउटलेट टेम्परेचर है वो 30 तो क्रॉस फ्लो सॉरी काउंटर फ्लो होगा सर. तो 30 डिग्री सेल्सियस है आउटलेट इनलेट पे सॉरी. और आउटलेट पे द टेम्परेचर इज वेरिंग. सो फॉर एग्जांपल फर्स्ट केस में हो जाएगा LMTD.
You assume any values, you get some LMTD. ठीक है, fine. उससे आगे.
So the as जैसे temperature difference जो temperature difference with respect to the refrigeration का जो टेम्परेचर है वो
refrigerant
चेंज हो रहा
temperature is same
है। हाँ, उसके
because it
रिस्पेक्ट
is
में
fixed.
सर जो आउटलेट का टेम्परेचर चेंज हो रहा है,
Outlet of water.
या आउटलेट ऑफ वाटर, उससे हीट एक्सचेंज में फर्क आना चाहिए ना सर, क्योंकि सर वो
वही
थीटा
बताइए.
है मैं, और अपना यू जो होता है
What
वो
is the physical interpretation of LMTD?
LMTD gives you the mean temperature at which the heat exchange is happening, right? मतलब mean
So
temperature
it is
difference.
a log mean temperature difference.
Yes sir.
Not arithmetic, it is log.
No, yes sir.
Logarithm.
Yes.
हाँ.
Yes
So
sir.
you will get the delta T.
Yes sir.
Temperature
Yes sir.
difference. So how it is linked with
हाँ,
this
so
change?
yes sir. So
Metrend.
there should be change in LMTD values for the 3 readings, right?
Let it be then.
So the overall heat transfer coefficient is a geometric factor U, and area is also geometric factor. So the only change
Overall
happening
heat
is
transfer coefficient is geometric factor. ये कब से आ
मतलब
गया?
सर मतलब मटेरियल प्रॉपर्टीज पे डिपेंड करेगा, परतों के लिए सेम रहेगा ना सर?
क्यों? Overall heat transfer coefficient is a function of the velocity, correct? How will you calculate H? Nusselt number hd by k.
Yes sir.
So there are
Okay, right.
thermophysical all factors, geometrical
Yes sir.
factors, all factors.
Yes sir. U is dependent on it. Yes sir.
Sir, sir, here, yeah, Rahul.
Yes, sir. There is a drop in the effectiveness of the heat exchanger, sir. Because
Why?
if we see the formula for the effectiveness, it is 1 minus e to the power NTU. Means number of transfer units is increased. So that is why there is a decrement in the effectiveness, and that is leading that the temperature change is not.
What is
The temperature
NTU?
drop is less.
What is
Number of
NTU?
transfer units, sir.
How you
Sir, it is
calculate
nothing
it?
but the UA by C minimum. It is here. It is evaporator. So here the means the number of transfer units we can determine, and then
You
if
explain
there is
this
a drop
properly.
in.
How
Yes,
would
sir.
you calculate NTU in this case?
So in that refrigerant part, there is a phase change. So in that case, the C value, which is the specific heat value, that is infinity, and C minimum value, which is of the water. So that UA by C minimum. C minimum is the specific heat of the water and heat transfer coefficient area. So the if we are increasing the mass flow rate of water, so in that case there is a drop. There is a drop in the NTU value, and that is nothing, that NTU value is decreasing the effectiveness of the heat exchanger.
You said UA upon C minimum, correct?
Yes, sir.
So what is C minimum value?
It is nothing but the m dot into Cp.
Of
M
what?
dot we are increasing
Of what?
of water.
Why? Who
Yes,
told
sir. Here,
MCP for the refrigerant? Why not?
सर वो इस केस में सर नहीं होता है ना सर, क्योंकि फेस चेंज हो रहा है तो फिर कांस्टेंट टेम्परेचर पे होता है, तो टेक्निकली डेल्टा टी इज टेंडिंग टुवर्ड्स जीरो, तो हम बोलते हैं कि उस प्रोसेस का सी इज टेंडिंग टुवर्ड्स इंफिनिटी। तो राहुल वही बोल रहा था कि वो सी मैक्स आपका, तो वो सी मैक्स हो जाएगा ना सर, एम डॉट जो भी हो इन्फिनिटी से मल्टीप्लाई करेंगे तो इन्फिनिटी आने वाला है, तो वो सी मैक्स हो जाएगा, तो सी मिन ऑटोमेटिकली आपका वाटर का आएगा, वही राहुल बोल रहा था।
Okay, fine. Then
राहुल आगे।
तो फिर there is a drop in the NTU, sir.
Okay, then
So NTU में there is a drop in the NTU, then that leads to the drop in the effectiveness of the heat exchanger. So फिर the increment of water, which is in ideal case, that is going to be in this case that would be less than the ideal case because of the drop in the effectiveness. So
you are requested to write this down and show the screen. I'm not able to analyze it. Write down on a piece of paper and explain. जैसे हम लोग क्लास में सिखाते हैं ना आपको, वैसे आप सिखाओ. very difficult for me to imagine what you are saying.
Okay, sir.
Sir, I was saying that, sir, for a given value of Q, we have Q is equal to mc delta t. So सर जैसे जैसे मास फ्लो रेट बढ़ रहा है, कम हो रहा है, तो सर डेल्टा टी बढ़ रहा है. तो जैसे जैसे डेल्टा टी बढ़ रहा है, तो सर उसके साथ जो इरिवर्सिबिलिटी वो भी बढ़ रही है. सो सर वी कैन से दैट मास फ्लो रेट जैसे जैसे बढ़ेगा वैसे वैसे इरिवर्सिबिलिटी बढ़ेगी और सीओपी कम होगा.
नहीं, कौन से टाइप की रिवर्सिबिलिटी? स्टेटमेंट इज करेक्ट, यू हैव टू डिफेंड इट.
सर फाइनाइट टेम्परेचर ग्रेडियंट.
What makes it on to fall on the lower side? ये अभी तक आंसर नहीं हुआ. Irreversible
So, sir,
बढ़ेगी, ठीक है. Which type of irreversibility? What is the driving
So,
factor
sir,
which will drop down the temperature? See, if your
Right.
m dot is reducing, एक simple case ले लो. M dot is reduced by half. Delta T has to increase twice. But it is not going. It is going up to 1.8. So, what is the factor responsible for this 0.2 difference? That I want you to tell. Don't just say irreversibility. What kind of irreversibility? Are you getting the question?
Yes, sir.
So, what is the driving factor which is not allowing from 1.8 to 2? Reversible होता तो 2 हो जाता. Irreversible है तो 1.8 तक ही पहुंचा. Instead of twice the delta T, it is 1.8 times the delta T. So, what is putting that restriction? You all are on the same line. You have to just put it in proper words. Rahul, show the screen.
Yes, sir. Yes. Once. Hello, sir. Sir, in that formula, effectiveness equals to 1 minus e to the power NTU. In that case,
Minus
NTU
NTU.
nothing but the... Yes, sir. Then UA by C minimum. In that, if we see the mass flow rate, we are increasing m dot Cp. When C minimum is value is increasing, so there is a NTU is decreasing. So that is leading to the...
Why it would decrease?
Decrement. Yes, sir.
In that in proportional way, why it would decrease? You are saying m dot into Cp. Cp to constant है. Finite
Yes, sir.
value is not changing. M dot you are changing.
Yes, sir.
U is constant. A is constant.
और सर यहाँ से जो राहुल बोल रहा है उसका एग्जैक्ट उल्टा हो रहा है ना सर. अपना मास फ्लो रेट जैसे जैसे डिक्रीज हो रहा है, वैसा कुछ इफेक्टिवनेस में हमारा फर्क कम होना चाहिए. तो राहुल का जो कंक्लूजन है वो एग्जैक्टली अपोजिट है ना सर. मतलब मास फ्लो रेट इफ इंक्रीजेस, द इफेक्टिवनेस इज डिक्रीजिंग.
हाँ, तो माइनस NTU है ना. e raised to minus NTU.
Yes, sir.
It's not plus NTU.
Yes, sir. Mm-hmm.
E raised to minus NTU. Huh. So Rahul continue. M dot is increased, Cp constant, U constant, A constant.
Yes, sir.
So what would happen?
तो NTU ड्रॉप हो गया सर.
Hmm.
तो NTU से इफेक्टिवनेस ड्रॉप हो जाता है. तो
Okay.
फिर Q absorb is less. इसलिए Q absorb की वैल्यू कम है सर.
So increase in mass flow rate, your effectiveness reduces.
Yes, sir.
Now how you will link it with the what I can say is COP part?
Yes, sir. So in that case, yes, sir. In that case, MCP delta T, the M dot which we are decreasing, that is not the rate with which we are decreasing that M dot. The rate which with change in temperature is not both rate are not same. So that's why the Q absorb is dropped.
So what would you suggest? Higher M dot or lower M dot?
Sir, higher M dot.
Higher M dot. Higher M dot के M dot you are increasing. Your effectiveness reduces, correct?
Yes, sir.
So effectiveness reduce हो गया तो डेल्टा टी कम होते जाएगा. Hemant pointed out the same thing.
Yes,
If
sir.
your effectiveness is 90%, that means your effective heat transfer is only 90%, not 100%. Your delta T, let's say X amount होना चाहिए तो उसका 0.9 X times होगा. Am I right or wrong?
Yes, sir.
Yes, sir. Yes.
So better is higher M dot or lower M dot?
Higher M dot.
How different?
Sir, M dot is higher. So in that there is an increment in the effectiveness, sir.
Yeah.
So I think I was wrong, sir. If we increase the mass flow rate, then there is a drop in NTU, and that is increasing the effectiveness of it.
Now you are on the right track.
Yes, sir. Yes.
Huh.
Understood, sir.
Fine, Srikant, show the chart.
Yes, sir.
It is e raised to minus NTU, not plus NTU. It is 1 minus e raised to minus NTU. So now if you observe m dot is reducing, delta T is increasing, but we have found out that it is not with the same proportion. So according to the first law of thermodynamics, whatever is the heat rejected by the water has to be absorbed by the refrigerant. Do you agree?
Yes, sir.
So m dot Cp delta T, water part, and let's say m dot into HFG for the refrigerant part have to be same.
Yes, sir.
They are not.
Yes, sir.
Correct. We are calculating the refrigeration effect not in terms of the refrigerant flow H1 minus H4 for the experimental part. We are calculating it from the water part. In the graphical part, we have discussed everything related to the refrigerant. That is why we use the pH chart of the refrigerant. But in the experimental part, we are not able to calculate any of the properties related to the refrigerant directly. So what we are using is the water part, other part, correct?
Yes, sir.
What we have observed is water can give more amount of heat, but it is not able to. If I reduce m dot, then delta T would have been greater. Water is rejecting the heat. So it was able to, for the water to reject the heat on the larger scale, but it is not able to reject it. Why? Reason being the effectiveness of the heat exchanger. Evaporator is a heat exchanger, condenser is a heat exchanger. So if you observe the formula for the effectiveness, और ये आपका सेम 5 हो गया है heat transfer force. I have the full authority to assume this. So effectiveness for the phase change equipment, condenser, evaporator, whatever it is a simple one, 1 minus e raised to minus NTU, in which if you substitute for the increase in m dot, the effectiveness is reducing, sorry, NTU reducing, and you are putting e raised to minus NTU, not plus NTU. So that will again become like inverse, and as such your effectiveness increases. Correct? Sorry, reduces. So that is why for the higher mass flow rate you are getting better performance. So what we assume for the with respect to the first law of thermodynamics, that total energy remains same. So whatever is the sensible heat rejection by the water must be equal to the latent heat absorbed by the refrigerant is not practically possible because of the effectiveness. Effectiveness would have been 100%. Then first law is getting satisfied. The irreversibility is in terms of the effectiveness of the heat exchanger, effectiveness of the equipment itself, and which is having the standard formula as far as any heat, no, not heat, sorry, phase change equipment is concerned. So you go on increasing the mass flow rate, there will be subsequent change in terms of the NTU, and naturally when substitute that NTU part into effectiveness formula, there will be subsequent change in the effectiveness. So what I want you to draw some kind of graphical interpretation with respect to MTU and effectiveness. Correct? Y-axis is effectiveness, x-axis is MTU. Sorry, M dot. You know the formula, you know the internal relation. Assume any values for the water part. M dot you know, delta T you know, CP standard value. M dot CP. And U and A, you assume any value because all three readings it is anyways constant. Correct? Your slope may differ, but your relation would be the same one. Let's say it is near one. The slope may be different, depend on the assumption values, assume values for U and A. Assume unit value. Your U is something 100 and area is 1 meter square. Anyways, it is heat transfer area. So let's say per meter square. क्या फर्क पड़ता है? And what would be the nature of this curve as effectiveness versus m dot? And that is what will give you the absolute crystal clear concept in your mind that when you increase the m dot, what changes? NTU changes, then accordingly effectiveness changes, and then accordingly your delta T, which should have been the theoretical value. Let's say, as I took the example while discussing with Ritik. So let's say m dot is reduced by half, and then delta T has to get increased twice, but that is not getting increased by twice. It is increasing, but not up to 2 times. It is 1.8, and who is responsible? That is that effectiveness. So how is the change in the effectiveness with respect to change in the mass flow? Try to find out this relation. That is something which you have to add in your conclusion. This is what is conclusion. Okay? Don't tell me this is increasing, this is decreasing. That is the observation. Now tell me what extraordinary rocket science discussion we had. First law of thermodynamics, SEM 3. Effectiveness of the heat exchanger, SEM 5. Everything already known to you. Now you are in SEM 8, on the verge of getting passed out. Had we discussed anything extraordinary? I was asking continuously the same question. What kind of irreversibility? Irreversibility is also done in SEM 3. At that time, you were not aware with the heat exchanger part, so effectiveness not taught to you. But in SEM 5, that was also over. LMTD and effectiveness NTU method both are like what I can say, two sides of the same coin. You can analyze the performance of the heat exchanger. If the temperatures are known, fine, then with the help of LMTD approach. And if the temperatures are not known, then with the effectiveness approach, effectiveness NTU. Correct? Same for heat transfer. I hope you will.
Yes, sir.
Huh. So then the effectiveness is a very strong function of the mass flow. You have to prove it. You know the formula, assume any standard value, and try to plot the graph.
Yes,
And
sir.
tell me whether it is a linear one or the logarithmic one or whatever.
Okay, sir.
ठीक है आपके ज़्यादा से ज़्यादा स्लोप चेंज होंगे बेस्ड ऑन द assume values,
Yes, sir.
but the nature would be same.
Yes, sir. वो ट्रेंड दिख जाएगा सर हमें.
हाँ, we have to find out the nature because as we are
Yes.
discussing that m dot is half and delta t is not 2 times, then what why or rather what would be the value? If it is linear one, then maybe 1.8 times. If it is logarithmic one, then it may log of some factor. So we can very easily find out this relation, and that is the governing part as far as the inability of the refrigerant to absorb the entire heat. Do you agree? Heat exchanger में हो क्या रहा है? Water is ready to give the heat, but refrigerant is not ready to absorb that much because of the restriction. What is the restriction? Effectiveness. So water capacity to reject the heat is much more, but refrigerant is not able to absorb it. So that is why water part cannot reject that much. I am ready to give Hemant 100 rupees. Okay, but Hemant is ready to take only 80 rupees. What is the final transaction? Only 80 rupees. Whether it is on my side or Hemant's side. Do you agree?
Yes, sir.
Correct? मैंने 100 रुपीज दिया हेमंत ने 80 लिया तो बाकी गया किधर? There has to be the accountability. So that means water, that means let's say me, ready to give 100 rupees. Water is ready to give more amount of it. But due to the effectiveness of the heat exchanger, the refrigerant, in bracket Hemant, is ready to absorb only finite amount of it, not the total. Do you agree? So that is why when you read the temperatures or let's say any property in terms of water flow, which is the direct indication of the refrigerant part. Your refrigerant is not ready to absorb everything. There is a restriction. So even the water wishes to reject, it is not able to do so. So that is why even though mass flow rate is reduced for the water, the delta T is not in the corresponding sense. It is increasing, but not in the corresponding sense. Are you getting it clear now?
Yes, sir.
Okay, so first law of thermodynamics getting satisfied. Mass flow rate reduces, delta T increases. But they are not equal because of the irreversibility in terms of the effectiveness of the heat exchanger itself. So our job, like this is the theoretical description. So the next job is to find out the nature of the effectiveness with the help of the mass flow rate. You assume any suitable value, try to plot that graph and show me. That completes your conclusion. Do you agree?
Yes, sir.
Fine. So plot the graph and show me.
सर
Yes.
सर जो अभी राहुल ने बोला सर और आपने जो कंक्लूजन में बताया कि ऑल्दो इट्स अ स्ट्रॉन्ग फंक्शन ऑफ मास फ्लो रेट बट सर मैं अभी वही फॉर्मूला लिख के देख रहा हूँ सर तो एग्जैक्टली उल्टा आ रहा है सर मतलब जैसे अपना अभी मास फ्लो रेट हमारा डिक्रीज हो रहा है तो एनटीयू बढ़ रहा है
यस
सर तो एनटीयू बढ़ेगा तो 1 माइनस 1 बाय ई रेस टू एनटीयू है तो ई रेस टू एनटीयू ऑल्दो बढ़ रहा है तो 1 माइनस ई रेस टू एनटीयू डिक्रीज हो रहा है
1 माइनस
ई रेस टू माइनस एनटीयू है ना
हाँ तो 1 बाई ई रेस टू एनटीयू है ना सर तो ई रेस टू एनटीयू
बढ़ेगा
बढ़ेगा तो 1/e⁻²⁰ डिक्रीज होगा ना सर?
तो बराबर है ना,
तो
1
1
माइनस e⁻² कम ही होगा।
हाँ
सो m डॉट बढ़ेगा, इफेक्टिवनेस बढ़ रहा है।
नहीं
आपका m डॉट ज्यादा है,
नहीं
इफेक्टिवनेस
सर,
ज्यादा है।
सर वही जब मैं m डॉट डिक्रीज कर रहा हूँ तब मेरा इफेक्टिवनेस बढ़ रहा है।
अगर आपका
हाँ
m
सर।
डॉट अगर आपका m डॉट कम हो रहा है, आपका रिजल्ट टेबल सामने है। हाँ,
हाँ मतलब रिजल्ट्स के साथ जो कंक्लूजन था हमारा वो मैच नहीं हो रहा है, मैं वही बोल रहा हूँ।
क्यों?
वो मुझे भी नहीं मालूम।
नहीं, you tell me the trend. Your m dot
Sir,
is reduced.
sir, m dot is reduced, let's say. So, let's say MDU value is 1, m dot is reduced. So, e raised to minus 1, sorry, e raised to NTU reduces because NTU is reduced.
तो बराबर तो
हाँ, तो सर 1 upon e raised to NTU बढ़ जाएगा।
हाँ ठीक
तो
है,
1 माइनस इंक्रीज डिक्रीज हो जाएगा ना सर?
तो होने दो ना, वही तो मैं बोल रहा हूँ, ट्राई टू फाइंड आउट इफेक्टिवनेस वर्सेस एनटीयू। Ideally your effectiveness should be effectiveness versus m dot, sorry, ideally your effectiveness, why it should change for the heat exchanger? Reason is m dot only, because your mass flow rate increases, that means velocity increases, velocity increases means Reynolds number increases in the sense changes, correct? So that is why your effectiveness changes. Reynolds number change होगा तो सब कुछ चेंज हो जाएगा। Why you are trying to relate it with, or rather how you are trying to relate it with the what I can say, the readings? Let me know what Hemant is trying to say.
सर मतलब जो फॉर्मूला है वो तो इट्स नॉट मैचिंग विद द कंक्लूजन which we are expecting.
Why?
सर हम एक चीज एक फिनोमेनन को एक्सप्लेन करने के लिए डिफरेंट थ्योरीज यूज कर रहे हैं, so maybe this is not the right theory.
Why?
वो तो मुझे नहीं मालूम सर।
नहीं, why you are saying this? Why you have drawn this conclusion that this is not the right theory?
सर वही सर जो फॉर्मूला राहुल ने दिखाया उस फॉर्मूले के अकॉर्डिंग जा रहे तो फिर मास फ्लो रेट डिक्रीज होने पे इफेक्टिवनेस मतलब इंक्रीज हो रहा है सर। तो जो एग्जैक्टली रिवर्स है ना सर, हमारे केस में हमारा मास फ्लो रेट डिक्रीज हो रहा है और हमारा हीट एक्सचेंज कम हो रहा है सर। तो टेक्निकली हम देख रहे हैं अगर इस लाइन ऑफ थ्योरी में जाए तो फिर
रेट
रेट
मास
नहीं
फ्लो
सर,
रेट कम हो रहा है, इट इज रेट ऑफ मास फ्लो, डेल्टा टी तो इंक्रीज ही हो रहा है और होना भी चाहिए, फर्स्ट लॉ है।
हाँ सर डेल्टा टी इंक्रीज हो रहा है सर, बट जो हीट एक्सचेंज जो है जो इफेक्टिवनेस वही हुआ ना सर। आप मतलब एक हीट एक्सचेंज दो जो सिस्टम है आपका हीट एक्सचेंजर का, उसका जो एबिलिटी था कि हीट ट्रांसफर कर सकता था वो 100%, वो नहीं कर पा रहा है। और तो अभी हम क्या कंक्लूजन पे आए कि मे बी द इफेक्टिवनेस इज अ स्ट्रॉन्ग फंक्शन ऑफ मास फ्लो रेट, और जैसे जैसे मास फ्लो रेट डिक्रीज हो रहा है हमारा इफेक्टिवनेस भी डिक्रीज हो रहा है। ये एक हमारा कंक्लूजन था,
नहीं, दैट वी नीड टू चेक। वी हैव जस्ट सेड
हाँ।
कि अगर मास फ्लो रेट कम हो रहा है तो उसके अकॉर्डिंगली प्रोपोर्शनली डेल्टा टी बढ़ नहीं रहा। अब वो डेल्टा टी प्रोपोर्शनली बढ़ नहीं रहा, इंक्रीजिंग और डिक्रीजिंग, दैट आई डोंट नो।
यस सर, सो वो सर अभी हम ग्राफ भी बनाएंगे तो क्योंकि यही ट्रेंड आएगा और उल्टा ट्रेंड आएगा सर। मतलब जैसे
निकालो ना, वही तो चाहिए मुझे, निकालो ना। What
Sir,
we
अभी
have shown or we have discussed is that delta T is not increasing to 100%. So in the second reading it may be 90%, in the third reading it may be 80%, whatever it is, that we have to cross check.
yes sir,
That is what I want you to do.
सर तो जैसे जैसे मास फ्लो रेट बढ़ रहा है वैसे वैसे इफेक्टिवनेस बढ़ रहा है।
बढ़ना चाहिए, मतलब अगर ये थियरी हम सजेस्ट कर रहे हैं तो।
सर लेकिन सर बट
ठीक सर, हम ग्राफ बना के देखते हैं सर। मतलब जो
ग्राफ
ट्रेंड
बना के देखो, यस,
मैं
एंड
और
ट्राई टू
ऋतिक।
कोरिलेट इट विद दिस।
यस सर। और सर अगर
जैसा आपका मास फ्लो रेट चेंज होगा,
हाँ
वैसे इफेक्टिवनेस, ठीक है, एंड इफेक्टिवनेस की वजह से डेल्टा टी। ऑन योर एक्स एक्सिस देयर इज एम डॉट,
यस सर।
on the y-axis whether you take it NTU, then second y-axis effectiveness, third y-axis delta T. You realize it. एक इंक्रीज होगा, एक डिक्रीज होगा।
और सर उल्टा है तो फिर विल अगेन डिस्कस।
हाँ,
अच्छा ठीक है सर।
राहुल ने जो प्रपोज किया है थियरी, यू टू क्रॉस चेक ना। इफेक्टिवनेस का क्या हुआ, ठीक है, फाइन, दैट इज विद हेल्प ऑफ द फॉर्मूला। Now when you use this effectiveness for calculating the delta T, let's say how will you define delta T effectiveness? Actual delta T divided by theoretical delta T.
Yes sir.
Correct.
Yes sir.
So theoretical delta T which you don't know, actual delta T which you have actually calculated. So what is happening with the effectiveness? You multiply by the actual delta T, that will give you theoretical delta T.
Yes sir.
So ultimately, if there is a change in effectiveness, then you should be able enough to plot for effective theoretical delta T also, correct?
Yes sir.
करके देखो whether your theoretical delta T increasing or theoretical delta T decreasing. That is what I want you to do. So as I had said, your m dot mass flow rate is x-axis. Tell me different y-axis. Let's say first is NTU, increasing or decreasing. Then second is effectiveness, correct? And third is delta T. Delta T मतलब कौन सा, theoretical. Let's see. So effectiveness times the actual reading delta T, that will give you delta T theoretical. Check what delta T theoretical you get. Are you getting the point?
Yes sir.
Delta T actual is with you. Effectiveness you will find out now. The trend. So check for the delta T theoretical. And then we can comment increasing or decreasing. What we are basically discussing is towards the delta part. Effectiveness is not delta. We have to somehow relate it with delta, because what we are doing is not the mass flow rate, it is the change in the mass flow rate. For a particular mass flow rate, there is a particular effectiveness. And accordingly, there will be particular, let's call it as exit water temperature. Correct? We are getting the exit water temperature as the actual one. There will be some theoretical value of it. By considering that effectiveness as 100%. Ours is not 100%. So for a particular mass flow rate, there will be particular actual m dot, what you call, water exit temperature, and there is a theoretical water exit temperature. So our focus is towards the delta part, change. Try to find out. Are you getting what I am saying?
Yes sir.
30 degrees inlet is common. Now you have reached, let's say, 22 degrees Celsius. But what is the theoretical value? If the effectiveness would have been 100%, then what is the value? That you need to find out. Then similarly for 24 degree, एक 20 का reading है, 24 का, 28 का, let's say for example, I'm taking some random things, random values. तो 20 डिग्री वाला कहाँ पे जाएगा, 24 वाला कहाँ पे जाएगा? That deviation is of your importance. Fine or not? Delta T theoretical minus delta T actual. Delta T actual will be always lesser because effectiveness is less than 1.
Yes sir.
So delta T theoretical versus delta T actual. That thing is important. That is what is basically effectiveness. Okay, you plot the graph and then we will discuss. It
Okay,
will
sir.
take time. You have to assume some value
Okay, sir.
and then plot it and check. Fine. We will stop over here. Anybody has any doubt? Any query in the mind? No doubt. Very good. That means either I am a very good teacher or you have not understood anything. Only two probabilities. Fine. Should I end the meet?
Yes, sir.
Very good. Thank you.
Thank you, sir. Bye, sir. Thank you, sir.